So now we look at the specifications which define how the LTE or 4G system works. And these specifications are created by a group called 3GPP. It stands for Third Generation Partnership Project. It's a bunch of operators and vendors who get together and specify how mobile systems are working, and they are responsible for the specification of GSM, 2G, 3G, LTE, and then what will be 5G will also be specified by the same group. Before we look at the specifications themselves, just a little bit of an understanding of what the process of developing these specifications is. 3GPP has three parts in which, three stages in which the specifications are developed. There is stage one, which is the requirements, the service requirements phase. So that's the very first phase where the main service requirements, or how voice and how data is to be, what the service requirements for that are, and that they are specified by the stage one specifications. Once those are fairly mature, what starts is the stage two specifications, which is the architecture and the network element and the flows, and most of these slides will cover and the next slides will cover the stage 2 level details of the system. Once that gets specified, then the stage 3, which is the more details of the protocols, the state machine, the messages, what information elements needs to go into those messages, that's all part of stage 3. That starts after the stage 2 specifications are done. And then there are also some conformance testing specifications. That's about specifically for the mobile to interact with the network, because the network can be provided by a different set of vendors, and your mobiles can come from vendors who are not even providing your network equipment. And the timeline is approximately in this order of magnitude, along with the level of specifications getting more and more detailed as you go into stage 3. This process works for bigger features like LTE, and also for smaller features like emergency call services, or for home cells or femto cells. The stage 1 requirements will be written, and then followed by stage 2, followed by any kind of stage 3 changes. So in order to look at the specifications, to get the specifications themselves, let's just go straight to Google and try to find out where these specifications are. So if you're looking for 3GPP specifications, the best way to do that is to type 3GPP specifications numbering. And once you type 3GPP specifications numbering, it will take you to the 3GPP site, and which has the 3GPP specifications, and they are numbered here. The thing to notice is that once you get in here, it's very difficult for you to say which is the specification to look at. Key parts to see is that the 2300 series is the one that defines stage 2. So if you're looking for overall architecture level documents, you have to look into the 2300 series. The next series, which are which is important to look at, is the 3600 series, which is the one that defines your radio access network. So anything about radio access network, you look at the 3600 series, and then the stage 3 details for the core network are part of the 2400 series. So if you're looking at stage 3, you're kind of getting to the 2400 series. So let's just assume that we want to find out more about stage 2 document, and then we essentially click on the 2300 series, and what will come up on the next phase is a bunch of specifications which are in the 2300 series, and these are a large number. So you need to know what real specification you're looking for, otherwise you have to do some search. I've been doing work in standards. I know that 23401 is the stage 2 document for the EPC, for Evolved Packet Core. So I go on to 23401, I click 23401, and that takes me to the next page. That'll give you all the documents, all the versions of 23401. And we will cover this a little bit. So this is where you're supposed to get the documents. In order to get the document, you'll click on the release tab, and what you will see are a bunch of releases. And in order to get to the version of that particular release, you just click on this button here, and you will get release 8 version of 23401. And if you want the latest release version of 23401, you click on release 14, and you will get that version of 23401. Going back to the specification, so now, as we saw in the previous slide, there are a large number of specifications. The LTE system is not as simple to to specify as the previous slides have made, because the whole idea about the slides here are to make it system understandable. We come back to, here is the LTE architecture that we have seen before, and now we start looking at which are the specifications that apply to this architecture. As I said, the stage 2 architecture specification for LTE, the key one is 23401 and 36300. So if you're starting from scratch and you don't know anything about the system and want to learn at least the high level, these are the two specifications that you will try to pick up and try to read. Once you've figured that out, you would have figured out this architecture, and now you want to look at the various detail interfaces. So for the interface between the mobile and the network, we start from the left. 36331 is the most important document that you will be seeing. That is this document that specifies how the mobile, the UE, interacts with the base station. There is another interface which is not shown in the architecture, which is a very important interface, is the interface between the mobile and the MME. It so happens that for all the signaling messages, for authentication, for example, the mobile communicates with the MME. This is a logical interface, and obviously the communication will go via the E node B to the MME, but since this is logical, the specification that provides you about this interface is 24301, sorry. Then the interface between the E node B to the MME itself is specified by 36413, and this is the main signaling interface going between the E node B and MME. And then you have the X2 interface between the E node Bs, and that's part of the that's specified by 423 specification. And then you have the interface between the E node B and the serving gateway, which is just the GTPU interface, and that is specified by 28281. So now we have covered most of the interfaces between the RAN and the core network. We look at the core network interfaces. The S10 and S11 interfaces are GTPC interfaces, which are specified by 274. And as we kind of said before, between the serving gateway and the PDN gateway, or the P gateway, we both have a control plane interface, which is 29274, and the GTPU, which is used for the IP traffic of the user, and that's kind of carried in something called the GTPU protocol, and we will cover that in later slides. And then you have the interface going out from the P gateway out. Oh, before that, you also have an interface to the HSS, which is the S6 interface, and that's specified by 29272. You also have an interface then going out to the internet, and you may also go to the operator services, and that's from where you have the VoLTE servers, as we had kind of covered before. This is specified by 29061, and even though this is IP, you would say, why do I need a specification? There are a few things here that are covered, for example, DHCP part of it, and some DNS, and so there are a few more things that need to be specified, and for that 29061 is needed. You would say, oh, we're done. Not quite. There are a few more general specifications or important ones that you need to pay attention to. 23003 provides you with identifiers. It basically defines what is the identity of a mobile, and what is the format of the identity of a base station, how it is used. Then for DNS lookup, so for a E node B to find an MME, this is all supposed to be served by an IP network. We have some domain name server lookups, and that's specified in 29303. A key specification here for you to understand the security aspects of LTE is this 33401. It includes both stage 2, some architecture level details, and also stage 3, which are some more protocol details for security. So these are the key specifications now that we kind of find out about EPC. But there is another aspect of EPC that is also there, and which is the policy and charging, or how the operator charges you for traffic, and how does he provide QoS. And those network nodes we haven't covered so far in the previous slides, but there are a few more nodes which are there, and there are a few more interfaces that come about because of that. So from the operator service, as we said, if you're providing VoLTE, it'll request a box which is called the PCRF, saying give me QoS for this particular flow and this voice flow, and then the PCRF gets subscription data from the subscription, and then authorizes it and provides a rule to the P gateway saying give this flow a particular QoS, and then from the P gateway, it'll also generate, it'll meter the traffic. It says how many IP packets are going for voice and how many of these are data, and it provides a meter, the number of packets information to the billing part of it, and then here is where your bill comes out, and then you get the billing shock. Anyway, so that's the overall policy architecture. So if you want to get to know a little bit about the policy and charging, the specification that you will take a look at is 23203, and for charging aspects you will look at 32240, and then for these various interfaces that we have over here, there are a few more specifications that will come up, and you need to look at those specifications to find out more about them. There's a slide set in this slide with some more details of other specifications also are on SlideShare, and you can get to that. There are other specifications also, but these are the key ones that I wanted to let you know. Obviously, after all of that, you do want to find out about stage 2 details, about requirements. Then you will look at this specification 22278. Though for most engineers you are not going to be looking at this specification really. I mean, the key ones, as we kind of talked about, are these two that you will try to look at first. Now we will take a look at 3GPP releases. What are the main features in each release for LTE, and how is the documentation managed by 3GPP? So 3GPP releases is a project management technique that 3GPP uses for updating its specifications and adding new features. Let's see how it works. So release 8 of LTE came out in the first quarter of 2009, and that had the main LTE, the first release of LTE. It had the OFDM, the MIMO multiple antenna support, and then the overall architecture. So in April of 2009, what came out was, for example, the release 8 version of 23401, which was the 800 specification. So now, after release 8, 3GPP continued working on the next release of its specification, which was release 9, which was finalized or frozen in the first quarter of 2010. The key features that were added in release 9 were location-based services, where a mobile can triangulate its location from multiple base stations, the support of MBMS, which is multicast services, so multiple base stations can transmit the same information over some area in the network, and then we had femtocells, or what are called home cells also, so these are small base stations for your home. So these were the key features. There were several other features. So what happens during 2009, 3GPP was not only creating these new features, but they were also correcting a few errors in its existing specifications, and those corrections were updating their specifications every quarter, which was, for example, 810 was coming out in the second quarter of 2009, 820 in the third quarter of 2009, and let's assume in the third quarter of 2009 it was decided that we can start adding specification for femtocells into 23401. So at that time, 820 was taken with the new changes for supporting of femtocells, and out came version 900 of 23401. And then further updates for the next 2 quarters were made, and they resulted in 910, 920. In the meantime, any corrections that were being made to the base features of EPC were added both to 910 and an 830 version with just the corrections to the release 8 features were brought out, and if possible even an 840. The new feature femtocell was just added here. The corrections were added both to here and to here. So that's the way the specification update is done. All right, so let's go ahead one more release. Release 10 coming out in the middle of 2011. This is a major release. This is what's called LTE Advanced. It had the main features of carrier aggregations. You can take 20 megahertz bandwidths, join them together to make them 40 megahertz, all the way up to 80 megahertz. You have an 8x8 MIMO scheme where you have 8 antennas on the base side and 8 antennas on the mobile side. Obviously, this is not the phone that you keep in your pocket. You also have enhancements to self-organizing networks and the support for emergency services. So let's say somewhere in the middle of 2010, based on the 920 version, it was decided that we can start creating the release 10 version by adding specifications for emergency support. And at that time, the specification that came out was the A00 specification. And any further updates for emergency were added, and they became the A10 specification, and so on. In the meantime, any corrections that were needed to features either for release 8 or release 9 were added both to the 810 version, and that resulted in also added to the release 9 version that came out to 930. And if the correction also was applied to a base feature of EPC, so something like attach or multiple IP addresses, you also got a 850 version of the specification. And that is the way 3GPP actually handles its specifications, and you'll get a hang of it eventually once you see a few of these specifications. Okay, so now we move to the next release. Okay, we move to the next 2 release, but let's just look at the release 11 that comes out in the first quarter of 2013. That has the main feature of COMP, which is coordinated multipoint, where mobile can get transmissions from 2 different antennas and can combine them, and also its transmissions can be picked up by multiple antennas and combined at the base stations. And then further enhancements to ICIC, or what's called HETNet, where you can have a macro base station and a pico base station, and they would coordinate themselves so that you can reduce interference. The next release that came out after 10 was obviously 11, and this was a major release again. Here we have device-to-device communication, so devices, your mobiles can communicate directly with each other without going through a base station. And this is also like your police walkie-talkie feature, and one of the main applications of this device-to-device is public safety. So LTE can now also be used for public safety, for police radios and your emergency support. So that was what release 12 specifications enable you to do, and the features that enable you to do that. The release after that, which came out in the first quarter of 2016, is release 13. And the key feature there is IoT, or what's also called M2M. So if release 12 was D2D, release 13 is M2M. And this allows for for very low power machines to communicate and send very small amounts of data to the network in an optimized way. It's not like you couldn't use LTE for sending small data, but the system is much more optimized, and there are new features that allow you to do that for IoT perspective. There's also a new RAT which has been defined to support IoT in release 13, which is called the narrowband IoT, which is much more optimized and very, very low power. Has the promise that on a single AAA battery, your device can last as long as 10 years. That's release 13. That takes us to release 14, which will be coming out in the middle of 2017. But there is no real G whiz bang feature actually in release 14, because what's going on is that now 3GPP has really started working on the next Tara feature. That's 5G. That'll be coming out in release 15, but you'll have to wait for that until the third quarter of 2018. So that's where activity in 3GPP is going. Though obviously it doesn't mean that this is the end of the road for LTE. It never is that way. There will be obviously more optimizations and updates and new features that we'll continue to add to LTE. So that takes us to the end of all the release management in 3GPP, and this would lead us into the next video, the next lecture where we'll cover the process of a mobile obtaining its IP address, the attach procedure, the mobile registers into the network, gets an IP address. We'll cover things about protocol stacks, what's called the access stratum and non-access stratum. You'll be wondering what that is, so you should listen to the next lecture. And till then,